Okay, this is sample problem 5.8. Using the data from Appendix 2, what you want to do is calculate delta H of reaction under standard conditions for Ag plus aqueous plus Cl minus aqueous to give you AgCl solid. Okay? So this is in a sense, it's a Hess's law type problem. But we're going to use the standard enthalpies of formation for this particular problem. So let's remind ourselves what the equation for this looks like. If we have a reaction, delta H of reaction under standard conditions is equal to the sum of the delta H of formation under standard conditions for the products times, oops, put a minus there, I got a little ahead of myself, times the number of mole of each product minus, and let me put brackets in here just so that it's clear what the notation is, the sum of the delta H of formation of each reactant under standard conditions times the number of moles of that reactant. Okay? That's not a minus, that's a times. I'll put a little dot there. Products minus reactants. Okay? Now, the equation has Ag plus Cl minus aqueous. Be very careful with these problems. Make sure that you do know the state of matter for each substance. And what I'm going to do is I'm going to go to Appendix 2. And I'm going to look up these values of delta H of formation. And, you know, in this problem, it doesn't say that it's at 25 degrees C, but it does say use Appendix 2. So Appendix 2 is at 25 degrees C. Okay? And the units are kilojoules per mole. Okay? So this is the amount of enthalpy change to form 1 mole of each of these substances. So for Ag+, if you look that one up, it's really early in the table because it's alphabetized, and Ag is the first element in the periodic table, at least of the common elements, because it's A. So Ag plus aqueous is 105.9. Now be careful. If it were Ag solid, it would be 0, because elements in their standard states are 0 generally. Okay? But this is not an element, it's an ion. Someone's taken an electron off of it and dissolved it in water. So it's not metallic silver like you look at a piece of silverware. This is an ion dissolved in water. You know, there's a lot of silver ions dissolved in the oceans. If you could extract all the dissolved silver in the oceans on the earth, you'd be a trillionaire. That's how much is dissolved in the oceans. But it's such a low concentration that you'd have to actually do it for the entire ocean. Okay, let's do the next one. Let's do the chloride. So chloride's going to show up under chlorine, so you have to go through all the elements and get to the C's, and then chlorine shows up. Okay, it's Cl minus aqueous, minus 167.2. Again, be careful. It's not Cl. It's not Cl2. It's Cl minus aqueous. Okay? And then AgCl solid, AgL solid is minus 127.0. By the way, in ALEX, the values are slightly different, just depending on where they got them. People will do these experiments and come up with values. They have slightly different values in ALEX. So if you're doing ALEX problems, make sure you use the pop-up table that they have on ALEX for these values. Don't use the values from the eBook. The one in the Burge eBook are slightly different. Now we're going to use these values in the equation, in the formula. Now, with this one, the balanced equation, every coefficient is a 1, so the n sub p and the n sub r moles of product, moles of react, are 1 each time. So mathematically, that makes it a little simpler. But remember, it's products minus reactants, not reactants minus products. There's only one product. So I'm going to write delta H of reaction would be, for the product, minus 127.0 times 1, right? And I'll put the square brackets there. Okay? The 1 is the coefficient in front of the AgCl. Minus, brackets, the first reactant is Ag+, which is 105.9. Coefficient is a 1. Plus Cl minus, which is minus 167.2. And its coefficient is also a 1. Okay? So let's go through. Let's do the products first. 1 times negative 127.0 is, of course, is negative 127.0. And then let's go through the reactants. The reactants are 105.9. And that's, I'm sorry, that one's positive. Plus 167.2, and that one's negative. Okay. 105.9 plus 167.2, which is negative. So it looks like that's negative 61.3. Okay, so products minus reactants. The reason I put that 61.3 in parentheses is because that's what I got. It's a negative. But we're subtracting a negative, right? So if you take 127.0 and that's negative, and you subtract the negative, that's like adding a positive. So it's like adding positive 61.3. And so you get a total of negative 65.7. Again, the units are kilojoules per mole. So in other words, it's exothermic, right? This is an exothermic reaction. It releases heat as it happens. So if you put Ag plus in water and you put Cl minus in water, they will react to form AgCl, okay? Silver chloride, there's your solid right there, okay? It's not much energy, though. 65.7 kilojoules per mole is not a whole lot. Alrighty? And there you go.